In this video, we're going to talk about two new options that are available in ZBrush 2020, and that is under Polypaint. If we go to the Polypaint menu under the Tool menu, you'll see we have the ability to colorize by draft and by thickness. Now, these are very important when you're doing 3D printing. We'll start by looking at from thickness. When we have an object like this bust here, and we want to 3D print it, first of all, we need to establish the scale, the object size. Now, once the object size is set, we need to make sure that parts of the object are not too thin to actually be printed. So for example, here in the ears, very often we find the ears can end up being too thin. So an object that's maybe 6 inches tall, the thickness of that ear will be too thin for some printers to build accurately. So previously, there hasn't been a way in ZBrush to check and see what your thickness would be over the course of your model. When you would have to send it to the 3D Print Bureau, and then their software, when they loaded it onto the tray, would say if there was a problem. Or if you're printing with a company like shapeways.com, their online tools will show you there's a problem in this area or this area. Now we're able to do this directly in ZBrush and fix any potential problem areas right out of the gate. So the first thing we need to do is set our object scale, because obviously the thickness is dependent on the overall object scale. We'll do that by going to Z plugin and going to Scale Master. And I'm going to click sliders to subtool size, and this will update the sliders to what the actual scale is of the object. Right now this is like 0.5 inches tall. Now I don't want that. I want this 3D print to be, let's just make it, let's say 8 inches high from bottom to top. Now I will click Resize Subtool, and it's going to tell me that resizing all the subtools based on the selected dimensions will create an XYZ value larger than 100. So it just needs to unify and then rescale. That's totally fine. Click OK, and it will cycle through all the subtools, and it will scale them in relation to each other. So the current selected subtool, the head, will be scaled to 8 inches tall, and then all the other subtools, the eyes, for example, those will also be scaled to match that ratio. So they will be scaled up so they're still sitting in their accurate relative positions. So now you see we have an 8-inch tall model. Now I have the holes filled in this. This is a watertight mesh, which is necessary for 3D printing. Now what I want to do is I want to create a Polypaint map or Polypaint layer here that will show me where areas are potentially too thin. To do that, we just go to Polypaint, and I will click From Thickness. Now we have min and max sliders here, and these are just fine at their default settings. What this is going to do, it's going to create a color range, and that color range is defined under Preferences, Analysis. Under Thickness, you can see this is our color range. Red is too thin, and then blue is ideal. So we're hoping to see things between blue and green, and we want to avoid things between yellow and red. So let's go ahead and do this now. I'm going to click From Thickness, and it's going to start calculating. So this could take a little bit of time depending on how dense your model is or how complex it is. So we're just going to give this a moment to process, and when it's completed, we'll come back and take a look at the resulting map. And here we see the resulting map. Any areas that are blue or green are going to be just fine. It's the areas in red that we're most concerned with. So if we zoom in here, you can see that these areas are usually where areas are kind of perhaps a little bit thin, like the eyelid here, or these wrinkles along the underside of the eyelid, the tissuey wrinkles here. Now, in my experience, these tend not to be that much of a problem as long as you don't have a lot of depth underneath them. It's these areas where it's basically a single mesh thickness that's protruding out. So if we were to hide the eyeball, you could see that that's just a protrusion in that eyelid. So what we'll do here is we'll just take the Move brush, and then very simply, we can just increase the thickness in this area. So I'm just going to use this to pull those eyelids back a little bit, take the standard brush, and build out the front of the eyelid. So by having this guide, this color-coded guide, we can see very, very clearly the areas that are potentially a problem. And then just go in and make some subtle tweaks to them. Now, just because it's coding as red here doesn't necessarily mean these areas will be a problem. You may find that these print just fine. When you supply them to your print bureau, they may see that it's not going to be an issue. It's nice because it gives you an opportunity to go in and judge these areas on your own and see any place that you may have missed. Because, you know, for example, those eyelids, I hadn't quite caught that I had that degree of draft behind there. So this is very, very helpful to be able to have a visual guide where I can see exactly where that might be a problem and then go in and correct it. Here at the wings of the nostrils, this is a potential issue right here. That's a little bit thin. I might just take the inflate brush and just do a tiny little bit of inflate there, and just that little bit of thickness in most cases is enough to take care of that issue. And I'm not terribly worried about these little bits down here that we're getting in between pores and wrinkles. Those are not an issue. The most important parts are these continuous red areas like we see on the nostrils and the eyelids. So let's see, let's do a little bit of inflate here on the ear. And we'll do a little bit of inflate here and here. And now we will do from thickness again, and we can see the changes that we've made will update the resulting color-coded map. So let's go ahead and click from thickness again. And here we see the resulting map. We have an improvement now around the eye area and the ears. And as I said, anything that's just sort of these little spatterings of red, I don't worry too much about. It's only when we have a large region of red or yellow, that's when I'm concerned and I want to go in and manually check that specific portion of the mesh. So that is from thickness, and that is very important for when we're doing 3D printing. Now, we also have a new option here called from draft, and this is when we're creating an object that we're going to make a mold from, or if we're trying to 3D print a mold itself. Draft is any area that curves back on itself. For example, here around the cheekbones, the mesh curves back on itself. So if we were to create a mold, so we could make a casting of this, let's say if the mold split right here, anything to the right of this is the pull direction of the mold. So anything that's curving under like that is going to lock into the mold. So that's potentially a problem. So when we're trying to create, for example, an object that's going to maybe be injection molded with plastic, that's a solid object in a solid mold, we want to be very careful with our draft angles and our pull direction. So just like with from thickness, I'm going to orient the mesh on screen and then click from draft, and it will once again process and then give us a color-coded map showing us the draft angles. So let's do that now. Let's click from draft, and I will pause the video while it processes this and then return once it's back. And here we go. Here you can see if we have a mold from here, all the areas of red are areas that are going to potentially lock inside the mold. The areas in green are going to pull accurately. So this allows us to see exactly where the mold parting line should be and areas that we might need to fill in. Just like we had to thicken areas that were red from thickness, here we would need to go in perhaps with the clay tubes brush and just correct this draft. So we would just fill in these areas so they no longer curve back. Now, this is really only something that you need to be concerned with if you're creating an object that's going to be a solid that's being pulled from a solid mold. Flexible molds like silicone molds and urethane molds, that's not as much of an issue. But anytime we're doing injection molded plastic, knowing your draft angles is very, very important. So this is extremely useful for those people that are interested in that type of manufacturing. Now, once again, I would go in, make my corrections, and then calculate from draft one more time. So let's just go ahead and fill this out a little bit more, and you'll see how this updates. I'll just take the move brush and pull that out a little bit. Orient my model on screen once again, and then click from draft. And there you see that draft on the cheekbones is now gone. Now I do have the option to set my direction here. I can set my pull direction, or I can invert the pull direction. So if I change to the side view here, for example, and then click set pull direction, and then do from draft once again, it will update that pull direction so it's coming from the side. Typically, we create the mold looking straight down the z-axis, but that's not necessarily always the case. It's something that is posed or asymmetrical. So now when we turn, you see there we have our new pull direction. This wouldn't be ideal because your seam line would be running straight down the face. So typically we're working from a view like this. Let's set the direction again, where the mold's on the sides. And there we have it. So these are two really important and helpful tools for anyone that's doing 3D printing, they're manufacturing, for jewelry, anytime that you're doing any type of 3D printing. It's very, very important to have total control over your thickness and your pull, your draft angles when you're doing molds. So these two tools are a fantastic new addition to ZBrush 2020, and hopefully you'll find them useful as you go forward and do more 3D printing. Thanks for watching, and I'll see you in the next video.